We now want to introduce angles to our complex number study that we've been looking at right now. And we're going to be looking at polar forms as well. So let's go ahead and let's get out that little plane that we've been looking at every once in a while, right? We have the one that we have over here. We know that this one down here represents real numbers, and that's where we would have our x value. We'd have some x value over here. We'd have some y value over here, and then we'd have our corresponding z value up here. We know that we would have a line that connects the origin to that z value. Go ahead and what color? We need some new colors here. Can't just all have the same color. There we go. So we'd have this up here, and we knew that this length is represented by the modulus of z. That's going to be the length, and that is going to be a real number. So we know this here is also a real number. So with that being said here, what if we want to introduce angles into this, right? So let's get a nice blue color. And what if we want to find this angle? So how would we find this angle? And not even so much how would we find this angle, but how would we introduce this angle into our studies? Because we want to have a bit of flexibility as to how we are going to solve these things. So what do we know already? Well, we know we have this z over here. We know that this is going to be a complex number. So we have the form x plus I multiplied by y, right? That's what we have for complex numbers. So complex number form. Now we want to know in terms of modulus of z over here and the angle. This modulus of z, we're also going to be just calling this by lowercase r. So I'll be using this as we go along. So just make sure you are aware of that. So in terms of modulus z, which is r, and the angle theta, what will x and y be? So we are going to want to use polar form, right? Polar coordinates. Now, polar coordinates is going to be that we are going to write our x and y in terms of r, right? So r, remember, r is going to be that modulus of the complex number z. It's going to be that length between the origin and our value z, a straight line through it. Now, if we're thinking about that again, right? I'll draw this out again because I want to make sure we're all on the same page here, right? We have our value z. We have some value z up here. We have our value x, and we have our value y, right? So x and y, make sure we are all connected like that. And we know that r is going to be this value here. So we call that r. Now, what's a way that we could write x and y in terms of r? Well, let's think back to just simple geometry, right? We can see here that this is clearly a right angle triangle. So we could use cosine and sine to write stuff in terms of the hypotenuse, which is r. So we know that cosine is for the adjacent, right? This here is going to be our angle. So we know that cosine is going to look for the adjacent one. In this case, this will be the adjacent, the one right next to it. So we can have r cosine of the angle theta, and that's going to be equal to x. We can have one up here for the opposite, right? We know sine will deal with the opposite. Talking about SOHCAHTOA, remember all this. This will be y is equal to r multiplied by the cosine of, whoa. I just said the sine and I wrote cosine. Sorry about that. Multiplied by the sine of the angle there. And those are going to be our polar coordinates, right? We are going to use those as replacements. So x is equal to r cosine of the angle theta, and y is equal to r sine of the angle theta. Those are going to be the ones that we are going to use. So what do we want to do here? We are going to go and we are going to simply re-enter the formula that we have for complex numbers, and we are going to replace these values, right? Every time we want to figure something out, we just return to the basics. We always remember that. So we know that the formula for a complex number is x plus I multiplied by y. Let's go ahead and replace x and y by these two polar coordinates. So we will have r cosine of the angle plus I multiplied by r sine of the angle. Just like that. And we can see that we can factor out r over here. So we will end up having r like this, cosine of the angle plus I sine of the angle. And that's going to be equal to our complex number written in polar form. So whenever we say polar form, whenever you see polar form, this will be a trick that will help you in calculus and anything you're studying. It's going to be writing your x and y's in terms of the cosine and sine of your hypotenuse that you're dealing with, right? So it's another way that's going to work, and you're going to see that this is going to help us make things easier. So we're going to look at something called Euler's formula, which is not something we are going to prove right now. That's a topic for another year. We don't want to deal with that right now. It's a little bit confusing. So we will go ahead and we will have e to the power of I with your angle is going to be equal to cosine of your angle plus I sine of your angle. So that is going to be Euler's formula. We are going to use infinite series or infinite sums to find that. We're not going to do it personally, but that's how we would do it, right? So for those of you who are curious, we figured this out. Infinite series. So it's not something that we are going to look at right now, okay? So it's just, we're just going to take this for granted and just assume it to be true. Actually solving this is something that we're not going to bother looking at. So do I want to continue? I think we'll look at some examples in the next video, okay? So we in this video, we were introduced to this polar form, and looking at it in the next video is going to be, we'll look at some examples to actually see how we are going to use this Euler's formula that we discovered. I didn't write Euler's formula, so I should go ahead and write that. Right over there. So we have Euler's formula. So thank you very much for watching. I guess I should call it Euler's formula, right? Because I hate people who don't pronounce it properly, and I don't pronounce it properly myself. Whatever, I'm a hypocrite. So thanks for watching, and I'll see you in the next video. If this video helped you out or any of my videos helped, subscribe. It means a ton. If you have any questions, leave them below. I'll either answer you in under 24 hours or make you a personal video for your answer, and I'll see you guys then.